Imagine a world where flying vehicles zip through the skies autonomously. How far do you think we are from turning this vision into reality? Welcome to the dawn of artificial intelligence in aerospace. This revolutionary technology is not just about creating smarter machines, but transforming how we design, ensure safety, and boost efficiency in the skies. AI's role in modern aircraft ranges from optimizing flight paths to predictive maintenance, dramatically reshaping the aerospace landscape. As we advance, the fusion of AI with aerospace is not just a possibility, but an inevitable transformation. But what exactly is AI, and how is it revolutionizing aerospace engineering? At its core, artificial intelligence, or AI, refers to systems or machines that mimic human intelligence to perform tasks and can iteratively improve themselves based on the information they collect. AI encompasses a variety of technologies, including machine learning, where algorithms are trained to make predictions or decisions without being explicitly programmed, neural networks, which are designed to recognize patterns in a manner similar to the human brain, and deep learning, which involves layers of these neural networks working together to enhance learning and decision-making capabilities. In the aerospace sector, these technologies are integrated into various aspects. For instance, machine learning algorithms are pivotal in predictive maintenance, helping anticipate potential failures before they occur. They also optimize flight operations by analyzing vast amounts of data to improve fuel efficiency and reduce delays. Furthermore, AI-driven design simulations allow engineers to experiment with and refine aircraft models digitally, significantly accelerating the development process and reducing costs. With these AI tools, engineers are not just creating better aircraft, but are also paving the way for fully autonomous flying vehicles. Let's dive into some real-world applications of AI in designing autonomous flying vehicles. One fascinating example is the project known as the Hawk 30, developed by a consortium of tech giants and aerospace companies. This solar-powered drone is designed to fly at altitudes of around 65,000 feet, serving as a high-altitude pseudo-satellite. The Hawk 30 uses advanced AI to manage complex tasks such as real-time atmospheric analysis, which helps in adjusting its flight path to maximize energy efficiency and maintain stability in varying weather conditions. Another groundbreaking project is the Ghost 4, an autonomous combat drone that employs AI for tactical decision-making in real time. The drone's AI system processes data from its onboard sensors to perform intricate maneuvers, identify targets, and even decide the best course of action during missions. This level of autonomy is made possible by sophisticated algorithms that simulate potential outcomes in